some of students. Okay, now we are recording. So yeah, but I probably have never met most of you. Like, nice to meet you, everyone. Yeah. So today I actually want to share with you some of our research for security and privacy on Internet of Things, which is one of the latest emerging platforms. Actually, maybe sometime in the future, I can come back and talk again regarding machine learning, security, and privacy, which is also security and privacy about these emerging technologies. But today, I just want to use this chance to also get to know you and understand a bit more about your interests. And also, I'm also going to have some advertisement because we are looking for undergraduate research assistants in our lab. Yeah. So basically, a little bit about myself. So I'm an assistant professor at UCLA ECE, so I like hacking and also like working on solutions to improve computer security and privacy. What I'm most proud of for my research is that we do have lots of security protections that get deployed in large-scale Internet of Services, like for example in Google, in Microsoft, and in Meta. And I'm continuing exciting things about security and privacy. And I really love cuddling with my cats when I have free time, and also hiking. I found like Los Angeles is actually a nice city with many different kind of things. I just wish I had more time to explore Los Angeles. And also I like to read books, and here are my 4 cats. They are all very lovely. Yeah. Actually, I don't have a photo with all 4 of them together because this one, this orange tabby, just doesn't like all the other 3 cats. Yeah, but the other 3 cats, they are very friendly and always like play together and sleep together. Yeah, so these are really close to my heart. How old are they? Oh, okay. So actually, this orange tabby is actually my first cat. I think she was born in 2016. So yeah, she's kind of getting a bit old now. And the second cat is so this is beautiful. And the second cat is a black cat is called Coffee. So these 2 are adopted from the local cat shelter. And his name is Coffee, and he's like born in 2017. And these 2 are much younger. Their birthday just like 10 days apart from each other. They were born in 2018, and this is a very beautiful and also naughty cat. And this one is actually the biggest one. Now it's already like 23 pounds or something. Yes, very, very big. And also he's very smart and knows how to open the door. Yeah, so I need to put a chair there to prevent him from getting into bedrooms. Yeah. So for my research, I'm a security and privacy researcher, but for security and privacy, we're actually looking to many different platforms. So my research has intersection with machine learning and in general about systems and also human-computer interaction. So we have done interesting work in lots of things like Internet of Things, which I will talk to you about, and also machine learning, security, and privacy. And in general, how to build usable security, secure and privacy preserving systems. And we are looking for motivated and smart undergraduate research assistants. You will have cutting-edge research opportunities, and also some of the projects are in collaboration with top industry companies. And also, like this project, and in my opinion, are pretty fun. And also, there's real world problems. So you're working on something that's practical and makes sense, not just like some theoretical kind of work. And if you're interested, please email you a resume and a transcript to my email account. Okay, so today I want to talk to you about the security and privacy of Internet of Things. But let's start with the question. In your opinion, how do you define Internet of Things? What is really IoT?
Kind of like you have many devices connected through a network, like in your house or something. Little devices that each perform different small tasks.
Yes, that's very nice. So basically, small connected devices, right? Yeah, that's definitely belongs to IoT devices. Do we have other examples or other things you think also belong to IoT? You have a hands up at the same time. Maybe you can go first.
Yeah, I would say like some more complicated devices.
Yeah. Basically, lots of IoT devices, they have companion app on our smartphones as well. And lots of them are smart home devices that help us to control them. And I always love your answers in my classes. So. Yes, different kind of sensors also belong to IoT. So for example, in the industry, smart plant, kind of like smart manufacturing, we also have lots of sensors. Like for example, we also have lots of sensors in self-driving cars, like the LiDAR, radar, these are also considered to be IoT. So IoT is a very, very broad concept. So it contains many different things. IoT involves factories like ships, trains, smart cities, smart homes, smart building, of course. And also some of the IoT involve mobile devices. So there are many things for IoT. Okay. The next question is, what do you think is unique about IoT? I'm asking you this question because if IoT is just like exactly the same as our previous computing systems, then we can just use exactly the same kind of security and privacy scheme that we already learned from like working on computer security for many years, right? So, but what's really unique about IoT in your opinion?
They tend to be like do like very smaller specific tasks, and as such, like they don't have a lot of computing power, or a lot of the times not even like they might just have like a firmware and no like actual software, and sometimes they might have to do like communications and stuff that they just sometimes they don't think about the security about them. Yeah.
Yes, exactly. First, many IoT devices are resource constrained. So they have very limited computation resources, and some of them don't even have a battery. So they get the power by doing energy harvesting from other devices. So, which means that they probably don't have lots of resources to do for security. That's why lots of smaller IoT devices are not really designed with security in mind, which can lead to lots of security problems. That's a great answer. And do you have any other thoughts regarding what's unique about IoT or what's new on IoT?
Constantly ongoing communication is often wireless devices.
Yes, we definitely have lots of wireless communications between IoT devices. So lots of IoT devices probably communicate to Wi-Fi or Zigbee, which is more low power. So there are lots of like sometimes also regular communications. They will send in, like for example, the sensors will send information regarding the reading, and also we will need to send commands to actuators to control different devices. Also a very good answer. Anything else?
There tend to be like a lot of them that will be connected to a single network, communicating with each other, and just like tend to be very hands-on. So people might not think, oh, I need to update. Like
yes. For IoT, yes, for Internet of Things, there's a concept about Internet of Trillion things, which means IoT can be at a really, really large scale. And also IoT hardware and firmware are usually quite outdated. We have a paper last year showing that some of IoT firmware even have vulnerability from 10 years ago, like known vulnerability from 10 years ago that's still not being fixed. And you can see how outdated they could be for security issues. So there are actually lots of interesting things about IoT, but here I summarize a few unique things like we already talk about so there are constraints in resources, and also we have a few new ideas about large scale and not easy to be updated. But here are also a few other things like they have new physical interface. For IoT, sometimes you also heard the concept of several physical system. Like I think many people treat them as equivalent. So several physical system means you are connected to both the server, like our internet, but also to the physical world. So we have lots of physical interfaces as in the sensors, where we need to look into the new ways of interfering with these devices. And also we have pervasive data collection, like local communication to send data. And also we have very diverse and also mostly closed source implementation of these IoT devices. So some of the more powerful IoT devices are heavily powered by machine learning because they want to be able to understand the physical context where the device is and also help us to make our life much easier. So lots of machine learning advancement here. There has been a very good research area called Tiny ML, which means that building lightweight machine learning on top of this IoT, smaller IoT devices. Okay, all these unique things about IoT actually provide us with lots of new challenges, but also opportunities. So here, the first challenge is the diverse and closed source IoT. So we have very diverse hardware, operating systems, and also diverse protocols. And most of these IoT devices are closed source, which makes it much harder to build a general security solution for all IoT devices. And the second challenge is the resource constraints. We need to consider about the power limitation, processing power limitation, and also storage limitation when we design security schemes for IoT. And the third challenge I observed is that the pervasive data collection is lots of privacy issues. We need to be able to understand what kind of data collection is useful for the functionality and what kind of data collection should not happen over privilege. Okay, there are also challenges regarding new interface. Now, some of the IoT devices, they don't even have a display interface. Well, traditionally for security, being able to notify users through the virtual, like you probably have saw something like when you click into a malicious website, Chrome will tell you, oh, this website is malicious, so you should not click onto it, right? So you might also see like red warning information regarding on the visual. So now we have new perceptual interfaces like through voice. It's just much harder to work with for building security and privacy solutions. But we also have opportunities. So that's why there are actually lots of new opportunities. Like for example, now there's lots of physical information that's already available from these IoT devices. Then we can improve security and privacy using this physical information and contextual information. So it's much easier to build robust solutions based on context. And the second opportunity is the machine learning, because the advancement of machine learning helps us a lot. So you probably use the ChatGPT. Yeah, probably not for homework assignment, but it's very good to play with. So ChatGPT is one kind of large language model, which is one example of advancement in natural language processing. So now like machine learning are so powerful that they can help us to automatically understand documents. And also they can help to simulate user interactions and also help us to classify events on IoT. So we can utilize the power of machine learning to help us build security solutions. Okay, another opportunity is also new interface. New interface is not just a challenge, but also provide opportunities, because now we have more interfaces to notify user about security and privacy. So we can build voice-based notifications, or we can build security notifications on VR, AR. So our wearable devices, so there are just many more channels we can look into and build more systematic kind of notifications. Okay, so now I have talked to you about what IoT is. We have also discussed about the unique opportunities and challenges in IoT. Next, I want to show how we answer these questions. First is that how to ensure user security and privacy against attacks from both cyber and physical space. So now, instead of just, we do not just need to defend against the cyber-based kind of attacks, which we know has been there forever, right? So you heard about cross-site scripting kind of attacks, buffer overflow kind of attacks, but we also need to worry about attacks from the physical space. Like, what if someone tampered the sensor reading of the smart car's sensor? Like, you actually will hit someone, although later tell you there's nothing in front of you, right? So, and also, like, how can we secure user on the diverse and complex IoT? And finally, if we have time, we can also discuss together what are interesting future directions in IoT security and privacy. Okay, next I will explain my answer both questions. First, for user against both cyber and physical attacks, I will show you how we use context-aware security IoT, and I will talk about two pillars. One is how we build liveness detections, and the second one is how we check policy for voice application relevant to medical information. Okay, let's get started. All right, so now, like, many people are probably use voice control devices. Maybe, like, how many of you have a Google Home or Amazon Sun Home? Okay, a few of you. And okay, how many of you are actually sometimes using Siri or other things to talk to your phone or smartwatch? Okay, a few more. So basically, voice control devices are becoming really pervasive. Actually, over 50% of U.S. households has at least one voice control device, like this smart home speaker sent home. Just similar to mobile applications, there are also lots of third-party software, like third-party applications on these voice control devices. They can do lots of things, help us to control smart home devices, even like start the car in the cold winter, although we don't have such problems in California. And they can help us to control our banking or do healthcare, even have smart healthcare applications. So, but one problem is that applications on these voice control devices, you can see that, I'm not sure that this is big enough for students who are sitting in the back. But if you have questions, let me know. You can see that user will send out voice command to the smart speaker, and smart speaker will send it to the cloud. And sometimes cloud also connected to the app server. And then this also, so all this action to control other devices or getting information happens in a remote cloud, which means the user might not really know what's going on. So there are new risks because of this. So the first kind of risk is from the physical environment. So there might be attackers that trying to inject malicious command to the smart speakers. So there have been TV advertisement and also YouTube advertisement talking about, hey, Alexa, buy something. Then Alexa did place orders when these ads are kind of played. So which causes a lot of issues. And another kind of we also need to worry about malicious apps. So because the apps are running in the cloud or even apps on third-party server, which makes it much harder to know what's going on. So this app can probably store lots of sensitive information of you, like listening for your information in the background, listening to your conversation in the background. Or the app might have unsafe activities interacting with kids, right? So there are lots of issues because of this new ways of interacting with our devices. Okay, so question is that how can we interact with voice interface securely? These are two challenges. The voice interface is very open and it's not very reliable, mostly because of the think about it, for voice command to be eventually executed in the cloud, it will need to go through things like speech recognition and also natural language processing to really know what's in the voice command. And sometimes we do have noise in the machine learning model, which make it less robust. And also, ranking of the third-party apps are more challenging because they are closed sourced, right? And also, they have unique interaction based on NLP. So you cannot use traditional software testing tools to test it. All right, so next I will show you our solutions. And for the first paper I'm going to talk about liveness detection, is actually trying to defend against the kind of attacks in the physical environment. So basically, we want to block malicious command injections. So that means that when there's another ad played on YouTube, say, hey, Alexa, buy this expensive product, then my Alexa can tell whether it's you, the owner of the device, talking to the smart speaker, or it's actually played from ads, right? It's actually not real human talking. So basically, the goal is that we want to be able to differentiate the things coming from smart TV or from your laptop or from your phone, and differentiate them from what's really a human actually speaking out a voice command. And there are lots of famous voice attacks on this. Yeah, so, but my favorite one is this one called dolphin attack. So this is also one of the best paper award and CSS a few years ago. So the dolphin attack means that if you inject malicious voice command in very high pitch, that only dolphin can hear it, then most of user, real human cannot hear it, but this voice command already being injected. So this is very interesting because previously, the smart speakers all have a very large range of listening to the voice. So dolphin attack at a very high frequency, so human probably don't even hear anything about it. So after this attack, we suppose now this new smart speakers all filter out this higher frequency now. So, but I heard like when people are very young, they might be able to hear more like higher frequency things. So maybe little baby can hear it, this kind of dolphin attacks. All right, there are also some progress in trying to detecting the liveness of the voice command to defend against voice spoofing kind of attacks. And there basically the liveness detection works because the observation is that human voice and the electrical device are just like sound differently. So if you can find the factors that represent human actions and also the factors that represent the electrical device actions, then we'll be able to differentiate them. So the current liveness detection has two kinds. The first kind is more like two-factor authentications. So for example, it will try to add additional sensors to capture the acceleration or like capture users' movements when user talk to the device. So like sometimes mostly actually ask user to carry additional devices, which is not good. Another way is that passive liveness detection, which is much better because it's only utilizes the collective voice samples. And the key idea is that the voice spectrum from authenticated user and spoofing are different because the way human generates voice is different from a loudspeaker generated voice. So when you speak, you listen and your face actually moves, and when loudspeaker actually is in a different ways of vibration. So even as a human, you probably can hear some difference, right? So basically, this is one of the most promising way of really provide a useful liveness detection. But basically, this kind of also has some limitations, mostly because of unstable spectrum. So basically, now you know that for the smart speakers, it's not just one microphone. It's actually an array of microphones, like 6 to 8 microphones together to provide you with better services. And if you look into each of the microphones, you'll find the spectrum is actually not stable. So this is the blue lines are authentic and this red lines are spoofing. You can see like from time to time, the spectrum are not that stable. Can you directly differentiate the blue ones from the red ones just from this? Yeah, it's kind of hard, right? So therefore, the question is that can we design an effective, robust passive liveness detection that will be much more stable? Okay. Can you guys hear me? Okay, on the on Zoom. Yeah, I hope it's okay. Okay. So we noticed that because smartphone speakers usually have microphone arrays, and this kind of multiple channels usually have more diversity. So we are thinking about, can we actually, sorry, I think I have a message. Okay, yeah. So as shown in the figure, comparing, so basically you have, this will actually have 6 microphone arrays. And we are thinking, can we actually use the multiple channels to make the detection more stable? Okay, the answer is actually yes, and I will show you more details. Okay, so we want to extract features from this multiple channel audios. You can see that this is one microphone array, and we rotate it for 90 degrees and 180 degrees. And we also ask the volunteer to speak about it. Now you have like this spectrum graph, which seems to be quite unstable. But if you use only fingerprint, basically trying to combine this fingerprint from each microphone together in a meaningful way, like considering their angle, then you have a stable spectrum, right? From the left to right, it's actually much more stable. The features are much more stable. So that's why we believe our method would work. So next will be some system overview about how the liveness detection we call array ID works. So we have a data collection module, pre-processing, feature extraction, and attack detection. So just like I'll briefly go over it. You can see like we have data collection, and we build our own microphone arrays, and we did some pre-processing, like signal processing of the information. I'm not sure if you guys will be interested in that. And we generate the fingerprint based on we have a certain method and calculating to extract the features from the model. And you can see that here are the calculated array fingerprint, right? Then, like you can see that the left one is authenticated user, and the right one is spoofing device. Now these two are quite stable, and you can see the difference is quite obvious, right? So for the spoof device, they have more like points on the higher top side, right? So now, like if you just use some machine learning models, to kind of like trying to do the detection, then it will be much more accurate. So we tried several different machine models, and actually you don't have to have very deep neural networks. Even some lightweight neural networks will actually get pretty good accuracy for this. So it's still pretty lightweight, and it's much more robust. We have tried many different experiments, like tried different settings with different speakers and also with different distances. And also we tried when people is moving around, we rotate the array, and we have different height of the microphone arrays, and we found they are all pretty stable. Okay, I have experiments with 20 users, and we have them speak different voice command. And so you can tell that the accuracy is pretty high. And also we also tried with other data sets not collected by us. Accuracy is also pretty high. The time overhead is pretty low as well. Okay, and we did various different experiments to show that this array ID is actually pretty robust. It beats the current CLR much better. Okay, so the first one I show you that how do we use the difference in human speak and also smart speaker speak to actually differentiate and affect spoofed voice command and real human speaking. There's lots of signal processing and but it's actually proved to be pretty robust. And next I will talk to you how do we check the policy on medical voice applications with natural language processing. Questions?
Yeah, but we use the array to calculate the category of how do you know like what different ways of them?
Yes. So actually we have an algorithm called angle arrival detection. So basically in that you will be able to know more or less the angle of the voice coming from, because you have lots of information also from the signal strings. So you will be able to more or less know the angle of the voice command. But in reality, even if you don't know exactly angle of it, you will still be able to get more or less reliable detections from the array ID, because you will have a speaker on different directions in the array of speakers. Yeah. Oh, sorry, array of microphone. You have different microphones in the array of microphone. Any other questions? Yeah.
I have a question kind of about the closed source stuff. So I understand with like pure software, like the incentive behind having closed source, because like it's like intellectual property. And I might understand that as well for like some of the bigger devices like Alexa or like Amazon Echo. But for like smaller IoT devices, like what's the advantage of going closed source? With the vendors selling the hardware, and like I feel like open source would have lots of security benefits.
It's just the manufacturer probably still want to protect their devices. I mean, even if they sell the hardware, they will still want to. They still have their own things in the firmware, right? So lots of time the firmware also closed off. Yeah, it's just like I feel they just like didn't really have the like atmosphere of having open source projects. Like it's different from like machine learning field. Many big companies still open source their model, but maybe not the state of art model, but it's still much better. But IoT devices are different. So that's why like it's actually really hard to kind of identify what's going on. But attackers will find out how to attack it by just like try different ways of doing attacks. And also it make it much harder for security researchers to provide help to them, because we cannot directly patch if they did something wrong. But we have to, okay, but we have something like black box ways of trying to test, trying to reverse engineering what happened, then we can tell them, okay, this is something you did wrong for security. So which is the third part, the third paper will be about. All right. So if you know other questions, I will move it to the second paper. By the way, I also want to know, like, when should I stop? Because I want to give you some teasers about my research and see if you guys, some of you might be interested in working with us. I know this is also midterm season, like you guys are probably pretty busy. So I didn't really plan to take the whole 2 hours. It's more about like talking to you and get to know you. I actually want to save some time so that you can introduce you to me, although I already know like 3 of you from my previous class. So yeah, so basically, yeah, when should I end my talk? Okay, sure. Yeah, so I will quickly go over the next two papers I want to talk to you about. And the second paper, I personally actually feel very interesting because it's asking the question like, when the software is written in a way like natural language processing, when you are talking to an app, which is a chatbot, then like, how do you know if the app has any sensitive behaviors? How do you really test it? How do you actually have apps to tell you more about this logic? Like, how do you trigger more activities from it? And the reason why we look into it is that there are lots of there are more and more developments for medical apps on this smart speaker. So both us and Google Home trying to get lots of smart health apps on their Y23 devices. But there were lots of complaints regarding this smart health app, healthcare app. Like I said, the terrible doctor. So we're just like, we want to know like what's really going on with these apps. But because they are more or less closed off for this voice app, we actually we actually need to do black box testing. And also because they are in a unique way of trying to interact with the users, we also need to build NLP-based, natural language processing-based testing tool to trigger activities. So first, I will talk to you about what health policies we checked. So you can see that this healthcare apps cannot store sensitive information. So basically that means that, by the way, a caveat here is that if you medical app actually pass the HIPAA certification, which is the Hospital Information Privacy Act, or something like that, then like, you can store sensitive information. But passing HIPAA is a very daunting task. So I think only 4 of the medical apps on apps actually pass the HIPAA. So most of them cannot really store any of these sensitive medical information. And they should not be providing life-saving assistance. They should not provide misleading information. And they should not sell prescription drugs in the black market. And they also need to provide proper disclaimers. But I think this one is mostly because Amazon trying to get rid of their responsibilities. So if the app provide disclaimers, they can get rid of responsibilities. But other ones I think are quite critical. So we need to test things in black box manner. And also we need to build natural language processing based testing to trigger actions. So we need to generate sophisticated testing. We eventually get multiple rounds of interactions, and also to trigger sensitive behaviors, we have leading questions and answer generation to trigger suspicious behaviors. And to improve the coverage of the testing, we also rephrase voice commands to just like help the app to understand what we are trying to do. And because we are looking into medical apps, and we need to determine whether some of the medical apps actually provide wrong, incorrect medical suggestions. So we also study with medical domain experts to look into different medical suggestions on these apps. All right, here's the basic system overview. We have both static detection module, which looks into the document of these apps and also some of the example commands from the apps. And we also have a dynamic detection module, which is more interesting, that's trying to automatically interact with the kind of voice apps. All right, so second module, we have both rule-based model and also CNN-based model. And for the dynamic module, you can see like almost like a chatbot. So we have the command generators. We usually start with some of the simple voice commands from applications. We also trying to run some machine learning processing on like one categories of app and trying to generate new voice. And we also have answer generator if we get a question. Like we first, of course, we need to classify our response. And we also need to generate the validation detectors and also rephrase the generators. I was thinking like this paper was published like 2 years ago. Now I think NLP is actually advancing again. So we now probably have a better chatbot to be able to trigger, to be able to test this voice applications. Okay, it's a simplified version about how we can test if the app stores sensitive information. We first will provide the sensitive information, like my lifetime is what kind of disease I have. And then like we will try to retrieve the information asking the application. And if the application provides the information, we consider as a violation because that means they have stored information. If they don't provide information, we consider as no violation. You can think about it. Is that really true? Yeah, sometimes a real bad malicious app could be, I collected your information, but I just don't tell you about it. Right? So they can choose not to respond. But this is the best we can do given the black box manner of the apps. All right, here are the results of the violation we detect. We can see like 30% of the apps actually store sensitive information. Actually, I want to point out. So some of apps actually store the information for a very long time. So even after you actually remove the app, or even you reset the device, somehow they still remember the MAC address of your device. And then when you download it again, it still match you with your older profile. So they actually remember you, even if you have deleted the app, or you said I actually unregistered my account, it's actually information is still there, which is crazy. You can see that sometimes they provide misleading information, and they actually don't really have a good disclaimer most of the time. Okay, so for the misleading information, they are actually quite interesting because, but I think if someone do a study now, there might be somewhat different because we found that most of the medical suggestions here are not really incorrect. It's just like not very helpful. But I think the same as some of our even ChatGPT, but ChatGPT are providing incorrect answers. I personally think this is because many of the applications are designed by matching in a database, a medical database, matching keywords in the medical database. So they didn't really understand what the user is asking. And also they don't know to ask the follow-up questions, which human doctors will definitely do. So there are like still gaps in the enforcement, and medical suggestions are not good for now. And also there are some suggestions we have for better safety. I believe in the near future, it still be a good way of human and also AI to collaborate. Like real doctors still need to work with these voice apps to provide better suggestions. And also there are really interpretation opportunities. All right. So next, I will quickly go to like how to ensure security on the diverse and closed source IoT. By the way, this warehouse work is also in the closed source IoT, but it's not that diverse. We only did it on Alexa and Google Home. But next I will tell you about very diverse situations. We actually tested on 9 different manufacturers. So, okay, this is we look into the IoT's messaging protocol. We know that lots of IoT platforms are cloud-based, just as the smart speakers, right? And the messaging protocol here is very important because it controls how these IoT devices are talking to the cloud. So basically on IoT platforms, the user and the device will actually communicate through the messaging protocol messages. These messages are usually critical because it might be alternative because like they will send user sleep pattern and also commands such as open the door. Here I'll show you the most popular messaging protocol standard, MQTT. This is simplified example workflow. So you can see that the broker use the connect and connect to communicate to start a connection, right? And then like after you start the connection, so then like there's some subscription. Basically most of the IoT model works in a way like you subscribe to a device, and once the device send an update, then you will get a message, just like you subscribe to a blog. I'm not sure if like if this kind of subscribing service are still, but it's quite similar in that sense. And of course, it's just similar to your subscription based on the topics here. You also subscribe based on the topic, about different status, the updates of the IoT devices. Okay, so there have been some attacks reported on this messaging protocol implementation, like denial of service attack, or sensitive data theft, or malicious command injections. So here we consider those. One is a neighboring scenario, which is attacker on the same network. That means that attacker can freely airdrop, like drop, modify, or inject messages. The second scenario is actually a pretty interesting scenario. So we call it tenant scenario, which means that the victim used some devices previously used by attacker. So this could include if you buy second-hand devices, or if you actually stay in Airbnb or in a hotel, so you're using device configured by others. So attacker might leave a backdoor on the device, and actually attacker can inject malicious command through it. Okay, the question is that how to build a system and ultimately evaluate the security of this messaging protocol implementations. There are 2 challenges. The first is very diverse and also customized messaging protocol. There are several different standards about messaging protocols, like MQTT, COAP, EMQP, the list goes on and on. And also, even for the same protocol, like MQTT, we have very different implementations on different platforms. And also, the system itself is, so this is an example about how the parameter topic and the messages actually customized in the captured traffic. So, and also the logic, interaction logic can also be customized. Like for example, when you have 2 devices with the same ID. In Google, the formal device will be offline, but in both devices will be online. So they deal every case, like almost every case differently. The second challenge is complex and closed source. So this is a stateful procedure, and you have multiple messages, and also the implementation is also closed source. So we build a project and model-based testing. consider two kinds of code. Which means a set of parameters from the message that should be confidential. You don't want anyone to get them. Like, because it might include things like ID or your password. A second kind of property are authentication properties that we extracted from the specification. So basically, this is a set of messages that should be authenticated. Because if you don't authenticate the message, attacker might modify the message, so we'll also get security issues. So this is an example of the machine of the broker and the device. We actually need to model this interaction logic with different messages. You can see that different kind of triggering trigger our state machine changes from one state to another. Okay, here's a brief overview of the MP inspectors, the tool we built to automatically verify the security of the implementations for messaging protocols. And I probably will only highlight the last two modules about how we actually reverse engineering the messaging protocol states, right? So first, I will talk to you about how do we extract the messaging semantics. So actually, extracting this messaging semantics is not really trivial. So sometimes for this example, we can see that it's actually in a very good format. In this case, we can just use pattern matching to match it, right? But it's not always the case. Let's say one example that you don't know what to really include password. In this case, we found that okay, in the documents of the platform actually defines the whole password. So we actually need to connect the traffic analysis with this NLP analysis. Okay, so we built an NLP assisted document to extract things relevant to basically identify the semantics of the parameters. So we did parallel speech parsing and dependency parsing to really extract the relevant relationship of the target and the content. Okay. Combining this together, we'll be able to understand most of the messaging semantics. The next is how do we detect the interaction logic? So here we apply active model learning to infer the interaction logic. So basically, I'm not sure if you guys have so get in touch of it, but basically you can imagine that you now already have a state machine extracted from the platform's documents, but the real implementation might be different. Okay, what will I do? I will just query the real implementation with the original model and say, okay, is this the same? If it's not the same, then we'll find okay how to fix the model. If it's the same, okay, means this code of the state transition is correct. So basically, that's what membership queries and equivalence queries are doing. Okay, and we need to support multiple parties, and we build a multiple party kind of extension. And also there are also non-trivial things we have to do to try to avoid real cases like endless traps in a circulation, or trying to make it more efficient. So we have lots of design choices we did. Okay, this one is also interesting. I'll just briefly go over it. You can see that lots of times we also need to know the exact condition, right? So for example, we want to know if the ID is actually growing or not. So we will fine tune the package to actually know the condition to get the validating predicates. Okay, we actually run 10 implementations from 9 billion IoT. So Microsoft Azure, AWS, and Ocean to Azure. And cloud lists all the major players. And we build our own testing platforms. So we identified 11 types of messaging protocol-based attacks, and actually 252 property violations. All these 10 platforms, they have at least one vulnerability. So they are all non-secure. So this is one example of attacks. By using the unauthorized response topic published, you can actually inject malicious comment into the victim device. All right. By the way, for all the 3 papers I talked about, we have open source implementations that you can play with. And we got real world impact, like 2 Smart actually adopted our tool to do their testing internally. We actually help them to identify lots of vulnerabilities in the implementations. Okay, I have talked about work we have done, but also I want to discuss with you what do you think are the interesting future directions in IoT security and privacy. If you have the time to work on any random project in IoT security and privacy, what do you think will be worth your time to do? So this will be about your interest.
I'm not sure if it's like within the same realm, but I was like AI and how like there's like the AI generated pictures and these feel basically art's original like art without their consent. Would that be within the realm of like what could be worked on with like security and privacy?
Yes, that actually itself is a very good research question. So basically, I think there's one paper from very recent. It's actually you raised a very good research question. There's one paper from researchers from University of Chicago. They actually built a tool to help the artists to prevent machine learning models from learning their art styles. Yeah. You can consider that is more like you can have more like a trademark on your own styles. So that's definitely a very important research question. It's probably more relevant to machine learning itself. And I can talk more about machine learning security and privacy maybe next time, which include all these exciting topics about how to make machine learning models more robust, more privacy preserving, and how to defend against the ethical issues in machine learning, right? So there are lots of interesting topics there as well. Yeah, that is a very good research question. Right?
Like rather than seeing if there's any as itself,
So you're basically suggesting that we can look into the network traffic and see if there are any malicious like packets getting into network traffic, right? So yeah, I think that's also a good way of doing sanitization of the network traffic. So like, for example, some of the firewall policies are actually doing something similar in that sense, right? Yeah, so for IoT devices, there might be attacks specially targeted on these devices. So you might be able to use some patterns to detect this malicious activity. Yes, yeah. Yeah, convoluted channel itself is also pretty interesting, especially IoT devices have a different kind of interfaces, right? So there's one very interesting paper, not directly relevant to convoluted channel, but means that different sensors can, although they are in different modality of sensing, like for example, that paper is, did you hear what I see? So basically, you might have a vibration sensor, you might have a camera, you might also just have a smart plug. They actually can sense the same kind of activity in different modalities, so that they can actually also share some of the information together that they can pair with each other. So definitely coverage channel is a very interesting topic in IoT devices. Other things? Yeah.
More like focus on standardization so that there's not like a consistency between devices, and then also more like
Yes, so you are talking about how patch can be quickly released, right? So I think that's a very important topic. So I want to know about in this case, how do you think it's how to generate the patches for the devices? So basically, can you explain a little bit more about your ideas?
yeah, like maybe or you were talking about how like a lot of the software is very outdated. And it's kind of maybe there's like some way to update the devices like automatically, or as soon as it happens, like somehow like the devices are more focused on faster as basically.
Oh, okay. So basically you want to be able to automatically update the device without much users involvement, right? Yeah. So I think that my work is just like another thing that a lot of these IoT manufacturers, they just like don't care about it. They are thinking, okay, so you just like should buy some new IoT devices, right? Yeah, so it's not like iPhone or some laptop. You actually, it's very expensive, but a lot of IoT devices are just like cheap. So they don't care about trying to maintain the security of these devices unless something really, really bad happens, right? So I think that the trouble will be like, how do you help this outdated firmwares or hardware to generate patches? We're actually trying to work on automated patching. So that's a very interesting topic. It's also relevant to this machine learning because you can treat this programming, like you can treat codes also as a language, right? So, how to automatically understand the vulnerability and generate patches is actually also a very interesting research question. Okay, anything else? Yeah.
Maybe not so much in security, but in the privacy, like what kind of, like the law honestly always tends to be outdated with technology. So like what kind of regulations do we want to make sure that these devices that all of a sudden are like in our private spaces that would never be possible before? Like they may inadvertently get all of this data, making sure that the manufacturers only do what they claim to do and not accidentally like want to release more information.
Yes, that's also a great question. Actually, in the new privacy regulations, such as the GDPR, which is in the European country, and also CCPA, which is actually in California, they all have some definitions about privacy for this different commercial devices. Like they always say like you should only collect data relevant to your functionality, and you should make user aware of what has been collected. It's just like the enforcement is always an issue. So we recently have a paper talking about how to automatically detect this kind of violations to the privacy regulations. And also, I think there are also some new regulations gonna coming out, like the AI Act in European countries. They seem to be pioneering a lot about the privacy regulations and ethical issues, but that's mostly in AI. Anyway, this is also a very interesting topic, and also affiliated with the UCLA's Institute of Law, Technology, and Public Policy. So we also host the events relevant to the intersection between technical issues and law and regulations. There's also will be opportunities for an engineering student to work with a law school student. I think we'll give you $5,000 and you can use it for your research as a gift money. If you guys work together on intersection between law and technology. I think there might be a call coming up, but that will be in the fall corner. Yeah. Okay, any more thoughts? Right. So for the decentralized communication, you also need to have, basically, it's the first problem is that how to establish trust if there's no central control of servers, right? And the second is that actually, if each of the devices itself is actually all of the devices are lightweight, then how do you build a protocol that's still robust, right? So some of the devices, so of course, encrypt, you will say, oh, I will encrypt all my traffic. But basically, if you then you also need to build lightweight crypto on these devices. So that's also another direction currently to build crypto technologies or security protocols that's lightweight that can work on these small devices. Yeah. Another direction is like actually can you actually have another central server to help to manage these devices? Then like how can you validate whether what happened on each of the distributed devices actually happens correctly from the central server? So these are all very interesting research questions. Okay, I have some thoughts, but I feel like you guys like proposing many more really interesting directions. So these are all very amazing. And I actually think you guys are interested in working on security and privacy, you should definitely check out in our lab. We are actively recruiting research assistants. I know this quarter probably is already in the middle, but like if you want to work with us next quarter or in the future, it would be good to just send me a note so that we can get to know more about each other. Yeah. Okay, so that's a question. Yeah. Yes, that's a very good question. So I think Vincent just joined our lab for working on a research project with Google. So I think we will get you through the whole like research procedure. And most of the times you will be paired with one PhD mentor who is quite experienced in doing research. And so we will start with trying to do some literature surveys with the research topic. So of course, in the beginning, we'll give you several ideas, several project options you can choose from. Once you confirm which one is more exciting and also more relevant to your expertise, or you are more excited to learn more about that field, then we'll actually get you started by first doing some literature surveys so that you understand what's going on in this area. And then like we will move on to, okay, so we have some ideas, we want to try it out, so we'll build some prototypes. And depending on whether you want to be more involved in it, like more like driving the project, or you want to get more experience and hopefully like if you think like you probably don't have that large amount of time, then you can help to build part of the prototype with my PhD student, potentially other students. And we build a prototype together, we'll run some experiments together, and we'll analyze the results. And then we'll say, okay, do we need to improve the prototype, and what are the gaps currently? And we will probably try to improve the prototype and get to a good system that we want to talk about. Of course, this is if you are building some system level kind of security defenses, but if you are doing a task, that will be slightly different. So we'll be doing security analysis and identify possible attacks. In the end, we hope we can write papers together. So for undergraduate students, depending on your contribution, of course, as long as you contribute to the project, you have authorship on the paper. And the order of the authorship will be determined by how much contribution you have. So we previously also have undergraduate student as the first author to publish in top tier conference and who ends up getting lots of PhD offers. So it depends on like how much contribution you have made. And most of students when they start in the lab, they probably want to just like getting on the project gradually. and we totally understand it, and we also give you time to ramp up. And since you guys probably still have quite a long time at UCLA, and we also hope to work with you for a long time and help you to grow. If you want to go to graduate school, then great. I think security and privacy is definitely a great direction to do research in. And if you want to go to industry, it's also a very important skill to be trained. And most of our projects are quite practical. So it'll also be an attractive project to put on your CV. Okay. Yeah, so I think I end around page 30. And if you want to introduce yourself, shall we just like go around the room? But I think you guys probably already know each other very well. Yeah. Yeah. Okay, so who wants to go first?